In the previous episode, Josh and Arobindo created a timeline to represent the growth of mold on a slice of pizza. They represented how the mold grew by a factor of 5 over the first period of time, and by a factor of 11 over the second. They determined that this meant that over the whole time that had elapsed, the amount of mold increased by a factor of 55. They argued that this meant that the total elapsed time was log base 3 of 55. In this episode, Josh and Arobindo will explore the reasoning of another student, Marcus, as he tries to solve the same problem. He said calculating log base 3 of 5 would tell him how much time passed between the first two checks, and log base 3 of 11 would tell him how much time had passed between the last two checks. To find the total elapsed time, he calculated log base 3 of 5 plus log base 3 of 11 equals log base 3 of 16. The students begin by saying whether they agree or disagree with Marcus and explaining why, using a timeline.
I disagree. I don't care. I disagree.
Because we knew from earlier, but now we have to explain it all. We have to justify our answer using a timeline, but okay.
Justify your answer.
Where is this log base 3 of 5 coming from?
Oh, it came from this.
Mm-hmm. And do you think that that's... So it seems kind of like you agree with Marcus.
No,
I don't.
We agree with this part of Marcus.
I don't.
We agree with this part of Marcus, but we don't agree with this.
Josh, do you think that this is this elapsed time is log base 3 of 5?
Yeah.
So we have this. Each day we go up by 3. So when we go up by 5...
Josh,
Okay.
It looks like Arobindo drew in a factor. What factor do you think that is?
Oh, that's times 5.
This is also times 3 to the something. And this question mark is what this is.
Arobindo and Josh agree with Marcus that the first period of time is log base 3 of 5 hours. They explained why this is using the timeline. They know that the amount of mold increased by a factor of 3 each hour. They also know that the mold increased by a factor of 5 over the first period of time. Arobindo suggests that this times 5 is equivalent to times 3 raised to an unknown exponent. This exponent represents the amount of time that has passed. This exponent is log base 3 of 5. Now, Josh and Arobindo will explain their reasoning for determining the amount of time elapsed over the second period of time, when the amount of mold increased by a factor of 11.
Okay, so then it's the exact same thing for this, because you have this and you times 11. And this is equal to times 3 to the basically log 3 of 11. Log base 3 of 11.
Arobindo explained why the second period of time is log base 3 of 11 hours, using similar reasoning as before. The amount of mold increased by a factor of 11 over this time. However, this factor of 11 must be equal to times 3 raised to an unknown exponent, where that exponent is the amount of time that had passed. Since the amount of time that has passed is the exponent to which 3 must be raised to get 11, it is log base 3 of 11. He and Josh will now use this information to develop an equation of their own to represent the total elapsed time.
Okay, so what do you think the equation should be? So you think it should be log base 3 of what?
55.
And that equals what?
That equals log base 3 of 5 plus log base 3 of 11. So this times 5 gets you this, because it's 3 to the something, which would get you the number.
Can you put in that 3 to the something?
It would be 3 to this. And for this one, it would be times 3 to the log base 3 of 11. So that's how you get this, and then, okay, I'm going to speedrun this explanation. So we have this times 55, and then you get this in the exact same manner, because it's 3 to the log base 3 of 55. Okay, this looks like a G. Okay, nice. And so that means this plus this is equal to this.
So why is this log base 3 of 5?
Because every day there's times 3.
Uh-huh.
You get 3.
Uh-huh.
And each day it's 1.
Uh-huh.
So the number of 3's you multiply is the number of 1's you get, which the number of 1's is the number of, what's it called? Hours? Yeah, I think she was doing hours.
Okay,
But I
so
can't.
this is the log base 3 of 5. This is the log base 3 of 11. So if you take them together, if you want the total time, you could add those two things. And you're saying that that's log base 3 of 55.
In this episode, Arobindo and Josh explained why they disagreed with Marcus's equation that was supposed to represent the amount of time it took for the pizza to grow moldy, and adjusted it to be correct. They argued the correct equation was log base 3 of 5 plus log base 3 of 11 equals log base 3 of 55. They agreed with Marcus that it took log base 3 of 5 hours for the mold to increase by a factor of 5, and that it took log base 3 of 11 hours for the mold to increase by a factor of 11. These factors can be represented as 3 to some exponent, where the exponent represents the amount of elapsed time it takes for the amount of mold to increase by these factors. They agreed with Marcus that the total time would then be log base 3 of 5 plus log base 3 of 11. However, Marcus said the total time could also be written as log base 3 of 16. Marcus seemed to think that he could add the 5 and 11 to get an equivalent expression, but Josh and Arobindo explained that this is not correct. Instead, the logarithm should be log base 3 of 55, because 55 is the factor by which the amount of mold increases over the entire time period. In the next episode, Arobindo and Josh will work with a similar equation and will explain what it means in the context of their moldy food.